Welcome to qnawire.
In this question, we have a collision between two protons. Okay, so before the collision, okay, a proton approaches another proton that is at rest. Okay, V2I equals to 0. Then there's a proton that's approaching at 500 meters per second. And then after that, okay, the two protons, they move off at 90 degrees from each other. So the projectile proton, okay, leaves the, after the collision, it went off at 60 degrees from the original direction. Okay, so I'm going to call this V1, and then the speed of the target proton will move away at 30 degrees from the horizontal, okay, with a speed of v2f. Okay, so we want to find v1f and v2f. Okay, so in this question, okay, so in part A we want to find v2f. Okay, so we'll be using conservation of momentum, and since this is a 2D collision, we will write the equation for x and y direction. Okay, and then our x and y direction is defined as such. Okay, okay, so along the x direction, okay, we have m v1I is equal to m v1f cosine 60 degrees plus m v2f cosine 30 degrees. Okay, and then along the y direction, okay, we have 0 is equal to m v1f sine 60 degrees minus m v2f sine 30 degrees. Okay, so we have two equations. So from 1, okay, we have v1I is equal to half v1f plus root 3 over 2 v2f. Okay, and then so we have v1I is 500. Okay, okay, and then from 2 we have 0 is equal to square root 3 over 2 v1f minus half v2f. Okay, so this means that square root 3 v1f is equal to v2f. Okay, and then we will solve the two equations. Okay, 500 is equal to half. Okay, we want to find v2f first, so I'm going to substitute v1f. Okay, this is 1 over root 3 v2f and plus root 3 over 2 v2f. Okay, okay, so we have root 3 plus 1 over root 3 v2f is equal to 1000. Okay, and then v2f is 1000 divided by root 3 plus 1 over root 3, and you get 433 meters per second. Okay, so this is part A. And then part B, we want to find v1f. Okay, so v1f is 1 over root 3 v2f. So you just put in the numbers and you get 250 meters per second. Okay, so this is the answer for the this is the speed of the projectile proton. Okay, and that's all for this question.